So for this lesson, we're going to be talking about this specific symbol that I'm sure you've seen here before. This will be known as square root. As you go more towards Algebra 2, you'll see that this symbol either represents square root or nth root. So for example, you might see the cube root of a number, the fourth root of a number, but we're just going to be focusing on square root. So basically, if you see this symbol, we think square root, what number multiplied by itself gives us 4? Well, I know that 2 times 2 is equal to 4. So the square root of 4 is going to equal to 2. Now, there are some radical numbers or square roots that we know give us nice, clean, whole numbers. That would involve or include square root of 1, square root of 4, square root of 9, square root of 16, square root of 25. But yeah, we're going to keep on going. Square root of 36, square root of 49, square root of 64, square root of, sometimes even I forget, 81, square root of 100, square root of 121, square root of 144. We know that 1 times 1 gives us 1. We know that 2 times 2 equals 4. We know that 3 times 3 is equal to 9. We know that 4 times 4 is equal to 16. We know 5 times 5 is equal to 25. We know 6 times 6 is equal to 36. We know 7 times 7 is going to equal to 49. We know 8 times 8 is going to equal to 64. We know 9 times 9 is equal to 81. We know 10 times 10 equals 100. We know 11 times 11 gives us 121. And 12 times 12 gives us a value of 144. So these are nice, clean, whole numbers that we get with these square roots or radicals. So you might see that word as well. Radicals and square root. So these we should know right now. These are the nice clean square roots, the nice clean whole number radicals. But what happens if we have, let's say, the square root of 50? Well, what number multiplied by itself gives us 50? I'm looking through all the numbers in my head right now, and there's no two numbers or one number multiplied by itself that gives us 50. We know 7 times 7 gives us 49. And we know 8 times 8 gives us 64. So I know that radical 50 is going to be some number in between this space here. So 50 is not a perfect square number. So I need to try to break down this 50. I need to try to think of a number that is a perfect square number. So which one of these factors, which one of these numbers is a factor of 50? Well, I can rewrite radical 50 as I know that 25 goes into 50, and that's a perfect square number. So the square root of 50 is the same as the square root of 25 times the square root of 2. Both of those numbers together, when multiplied, gives us radical 50. But now I can simplify this square root of 25. I know the square root of 25 is going to equal to 5. So it's going to be simplified to 5 times radical 2, or just as how we know that 5 times a equals 5a, we can combine these values together. Instead of writing 5 times radical 2, we can say 5 radical 2. Let's do another example. Let's make this smaller, put it out of the way. Let's take the square roots of 20. Again, there is no number when multiplied by itself that gives us 20. I'm going to try to see where radical 20 lies. I know it's going to be in between radical 16 and radical 25. So I know that number is going to be between 4 and 5. Let me break down this 20 into a product of two numbers where one is going to be a perfect square number. So which one of these perfect square numbers is a factor of 20? Well, I see that 4 is a factor of 20. So I can rewrite this as a square root of 4 times, and I know that 5 times 4 gives me 20. So it'll be radical 4 times radical 5, or the square root of 4 times the square root of 5. And we know that the square root of 4 is going to equal to 2. So our final answer is going to equal to 2 radical 5. Again, the key important detail here is to break down this radical into a product of two radicals, where one has to be perfect square. Now, sometimes you might have to know more than just these 12 perfect square numbers. I believe maybe up to at least 17. Right? So I know that 13 squared is equal to 169. So the square root of 169 is going to equal to 13. So keep in mind of what will be beyond these 12 perfect square numbers. So the square root of 169, the square root of 196, the square root of 225, and the square root of, I believe, 256. So square root of 169, as we said, is 13. The square root of 196 is 14. The square root of 225 is 15. And the square root of 256 is equal to 16. So let's say we were also, let's do one more. Let's do a larger number. Let's do the square root of 175. Ooh, I need to figure out what number, which of these perfect square numbers is a factor of 175. So I know 25 goes into 175. So that'll be the same as saying radical 25 times radical 7, which gives us 5 radical 7. Now, what if you choose a factor that you can still break down? Here's what I mean by that. Let's take the square root of 80. And I'm going to choose, let's see, which one of these is a factor of 80. I'm going to choose a smaller number. I'm going to choose 4, right? So I know that square root of 4 could be broken down as square root of 4 times the square root of 20. This will be simplified to 2 radical 20. However, we worked on this problem earlier. We know that we can still simplify radical 20 as 2 radical 4 times radical 5. So that will be the same as 2 times 2 times radical 5, or just 4 radical 5. Now, why do we have that extra step? Well, you want to choose the biggest factor from these perfect square numbers. So that means with radical 80, I can choose a larger factor that goes into that number. So if we look at 16, I know that the square root of 80 could also be written as square root of 16 times the square root of 5, right? 16 times 5 gives us 80. And we know the square root of 16 is going to give us 4. So we still arrive to the same answer, 4 radical 5. But you'll see here we did a lot less work to arrive to that final answer. So whenever you're simplifying radicals, try to find the largest perfect square number that is a factor, and always double check to make sure that your radical can no longer be simplified. So that one would be an example where you would have to keep on going. But if we looked at, let's say, radical 7, I know that I can't break down that number anymore. There's no two numbers that multiply to 7, that's itself.